Hi, today I would like to talk about mains filter with the snubber. A lot of people, you don't see, you don't believe. Do the filters and snubber networks really work, and do we really need them? I'm just going to do a practical demo today with two different sort of circuits. One, basically with the inductive load, and I'm going to be switching it on and off, and then with the antenna, broadband antenna, into a portable spectrum analyzer and pick up the harmonics induced into the mains cable. So basically the setup is like this. I've got 220 coming here, okay, going basically into the actual inductive load. Same exactly, inductive load, on-off switch. On-off switch, I'm just going to sort of join it, tap it in, on and off, on and off. And then, with a portable spectrum analyzer, I'm just going to measure the actual signal and harmonics induced back into the mains. So what I've done is I just used a broadband antenna, which I attached it with a with a peg, to the antenna, and the antenna actually picks up the signal induced and the voltage induced into the cable which is plugged into the mains. All right, so on that note, let me just apply the voltage over here, and then we measure on a spectrum analyzer. Okay, now I'm on the spectrum, and as I keep on applying, you can actually see it. Okay, and not only that, you can see it also the noise on that other spectrum analyzer. But nonetheless, you can see on the spectrum analyzer, I'm measuring it from about 2-3 megahertz to about 100 megahertz. And it is a fairly broad band noise. And I'm measuring exactly 39,5, my peak. My peak signal at 28,34 megahertz is about minus 39,5. So minus 39,5 dBm. Okay, and that is without the actual filter. That's direct mains plugged in into the actual inductive load, as I got it over there. Spectrum antenna picks up noise from the actual from the cable with the switch inductive load. Now what I'm going to do is I'm going to connect basically a second circuit, and that is I'm going to introduce a filter which has got a snubber network built in, and this is basically what it looks like. So I'm going to plug in 220 over there, 220 over there. Okay, I'm going to be using this actually as a switch, basically. Let me do it this way. Let me just connect it up. Okay, and the actual ground for the filter. And then, now on the output, this is basically my input now, which I'm going to be applying and using basically as a switch over here. So in actual fact, over here, actually I got the switch. Okay, so I'm going to be switching on and off with this wire tapping, just applying it over there. Okay, so now this is the actual filter that we actually built, and I just separated the actual snubber network, but usually we supply it with a built-in snubber network. But just for demo purposes, this is my snubber network and this is my actual filter. And watch what actually happens. So now the actual on the output of the filter and a snubber network, I'm just connecting my inductive load. Okay, so remember, this is memorized on the spectrum, and you can see it's extremely strong signal induced back into the mains, which is interfering with many different, with my TV, with everything. Okay, so now let me clear the screen. Now I'm going to be applying, basically, as I said, I got the snubber, I got the filter, I got the on-off switch, and of course I got my antenna plugged into a spectrum analyzer. So let's start from scratch. Here is my basically switch, which I'm going to be just connecting it over there. It goes into a filter, which has got the snubber network. And then, of course, here is the inductive load connected into the output of the actual filter. And watch now what's going to happen on the spectrum analyzer. Let's plug it in. Okay, let me just do it this way. Reset it again. Okay, let's do it now. Sorry. Okay, I wasn't holding properly. Okay, there we go. Okay, now, that's basically what it is. Okay, now, if you look at it very carefully, I'm still measuring it from 3 megahertz or 2 megahertz to up to 100 megahertz. And my maximum signal is at 28.34 megahertz, which is minus 66 dBm. So minus 66 dBm, that would give us exactly 5, that's 3, and whatever. That's approximately 33.5 dB attenuation. That's what I'm basically getting with my filter and with a snubber network. Now, to give you an idea, 33 dB attenuation would be approximately about 4,000 times I have attenuated plus minus 4,000 times I have attenuated the actual signal induced back into the actual mains, going, to my 15 amp plug where I have got it plugged in. So with this little demo, I have demonstrated that by using the filter and using the actual snubber network, like I got it over there, here is my input 220, here is my on-off switch, here is my filter with the snubber. And then, of course, I still got the inductive load. And here is my inductive load. I have reduced a signal by approximately 4,000 times. So harmonics anywhere from, as I said, from 1 megahertz up to 100 megahertz, I have reduced that noise. And that is good enough. Not good enough, it's actually too good. It will not interfere with any sort of operation of the electronic equipment around you and cause the havoc to your neighbors, to your other sort of electronic devices and things like that. And also, it's not detrimental to one's health because it is below the actual load line. And as I said, I've got it on the basically on the wall, the actual chart, and if you look at it, I have basically reduced the actual signal much lower with spikes and with whatever signal by combining my actual filter with a snubber network. So again, and as final, for the skeptics out there, do the mains filters and snubber networks work? Yes, they do work, and here is the proof. On that note, I hope I sort of entertained you in a sort of constructive way. And on that note, we speak again. Till next time, thank you for watching mains filter with snubber network, made by Batos Radio and TV. Thank you.